Okay, so we're diving straight into question 5, where we've got some STEM students between the ages of 20 and 25 who were surveyed about their confidence in the STEM subjects, that being science, technology, engineering, and maths. And the results are being shown in what we call a composite bar chart, where we've got the really very confident students being represented by the darkest shade of blue, whereas the students who are not confident at all are represented by white, and then a very light shade of blue for not really confident, so on and so forth. Okay, let's see what the question wants us to do. So scrolling down, it's one of these questions which are true, false, or unable to determine. Unable to determine has been evident in more recent papers, so that is an option that you need to be familiar with. But the first statement, it says, the STEM subject with the lowest percentage of students who reported they are somewhat confident or very confident was engineering. So let's just underline where it says or here, because whenever you see the word or, that should be giving you a hint to do an addition. So what we're going to do is we're going to take the somewhat confident part of the bar chart and the very confident part, and we're going to add them together. But we're looking to see whether engineering had the lowest percentage of students. So we'll scroll up and then we'll have a look. So our two options are somewhat confident, this shade of blue here, and very confident, the darkest of blue. So we're looking at the end of these bars. These are the colors that represent those two options. You could add the percentages together, but in all honesty, where everything is on the same scale here, that's not necessary. We can just highlight the part that we're looking at and do some comparison there. So for maths, if we highlight these two options here, so we've got 39% and 23%. And then for the next one, 27% and 10%, this is engineering. You can already see that this is lower. I can add the two together and get 37%, but you can see straight away I've shaded less. And for technology, we have this section here. And last but not least, for science, we have this part here. And hopefully you can see that engineering is definitely the lowest. Where they're on the same scale, we are able to do this. And I'll just put some red lines. So science ends here. Technology ends here, so they're pretty similar. And if you add up these percentages, you would find they're pretty similar as well. But engineering is significantly lower, and it's significantly lower when compared to maths as well. So that is enough to tell me that the statement is true. Engineering definitely had the lowest percentage of people. It had 37% to be precise, who said that they were somewhat confident or very confident. So that statement there is true. Next one, more than 100 students reported they were not confident at all at technology. So this is one where it could catch you out, in my opinion, because there's a little bit of detail that if you don't notice it, you're going to find this question, you're going to assume that you can't do it. If we scroll up, you can see somewhere that it actually tells you how many students took the survey. It's actually at the top here where it says 2,000 students. So if we become fixated on the graph and nothing else, it's easy to miss that bit of information. You might have seen it once, but then forgot it was there. So just bear in mind that you want to read the entire question again, and actually that information is given to you. So 2,000 students took the survey. It says more than 100 students reported they were not confident at all in technology. So if we go to technology, not confident at all is 4%, the 4% here. So we're doing 4% of 2,000. So 4% of 2,000. We'll type it on our calculator just to be sure. 4% represented by 4 over 100. Of is telling us the times 2,000. So 2,000, and it's 80. You might have done a little bit of mental maths there to see that it was less than 100, and hence the answer is false. But where we have the calculator, it's worth using it to double check. So that one is false. Last statement we need to look at is it says the students who reported they were very confident in science were the same students who reported they were very confident in technology and maths. And unlike before, where the information was hidden up here, this information is nowhere to be found, okay? Let's just make up a student and call them Barry. We don't know whether Barry was very confident in science, but then was not confident at all when it came to technology. We just don't have that information given to us, and we shouldn't assume just because they found one subject easy, it's going to be the same for the other. So this is an example of where you're unable to determine. You do not have that information given to you, so you are unable to determine whether that is true or false. We just don't know. Moving on to question 6. So here we have some group data. So we've got people who took a comprehension test and they've been summarized into groups. So there were 2 people who scored between 0 and 5, because it says less than 5. Where it says less than 5, I would argue actually that means they got 4. So if someone got 5 exactly, that would be a bit difficult to tell, but that's not what the question needs us to do, so that's okay. But less than 5, there were 2 people. There were 4 people who scored between 6 and 10. So 4 people, 4 students got between 6 and 10. 8 students scored somewhere between 11 and 15, so on and so forth. So hopefully that makes it clear of what the table is actually telling you. We'll just highlight here as well. It had a maximum raw score of 30. So that's important information. But it tells us in question 6 that if somebody scored 15 or less, they're going into a targeted teaching program. And we want to find what percentage of students are going to be in that program. Let's just highlight the students who are going to be part of this program first. So if they scored 15 or less, so these people here scored between 11 and 15. We don't know exactly what they got, but they definitely didn't get any higher than 15. So we include them. So 8 students there. These 4 students between 6 and 10, that's less than 15. And these students found the test quite tricky, so they're included as well. If we add those up, we've got 2 plus 4 plus 8. That is 14 in total. But we want to turn this into a percentage. So to turn this into a percentage, we've got 14 out of 50. If you can't see where the 50 came from, it tells us at the bottom that there's a total of 50 students. If you added up all these numbers here, you would get 50. But considering they've told us there's 50 in total, we can just use that information. This is a fraction. If we want to turn it into a percentage, we need to times by 100. So now we'll go to the calculator and type this in. So that's clear. 14 over 50. So 14 divided by 50 times 100 to turn it into a percentage. And you can see there we've got 28%. So our answer for this one is 28%. Question 7 is a different scenario. So here we've got someone who's paying for dinner. Kim and Lee meet for dinner. She has a burger and Lee has a salad. They each have a drink and each drink costs $4. So I'm just going to put this bit here underlined. They each have a drink, because if we only include one drink, that will catch us out in this question. But let's see what the question wants us to do. Kim pays for both dinners with a $50 note. That's kind of her. And we want to figure out how much change she should receive. So change is another key word. When you see change, it should be suggesting to you that we need to do a subtraction at some point. If you're trying to find the change or the difference, that is a subtraction. But before we do that, we need to total how much the bill was, because Kim is paying for everything. So over here, we've got Kim has a burger for $15.90. So there's Kim's burger, $15.90. Lee has a salad for $14.90. And they have a drink each. This is where you've got to be careful. They have a drink each. So you could do 4 lots of 2, or you could simply write that you're going to include 4 twice. and that will be the total of the bill. Let's type it in the calculator. I've done it in a column there so you can see what we have to do, but we have the calculator to help us, so let's use it. We have the burger at $15.90 plus the salad at $14.90 plus the drink at $4. So here we can just put 4. If you put 4.00, that would be helpful for non-calc question. For now, we can just put 4. The calculator will figure that out. That's one drink and another 4 for the second drink, and we get 38.8. But because it's money, just remember that is equivalent to $38.80. So that's what the bill costs, but we want to find the change from a $50 note. So what we need to do now is we need to do 50 subtract $38.80, because remember, we're trying to find a change. I'm just going to change my color to green. So we want to do 50 subtract the total cost of the bill, which was $38.80. If we was in the non-calc, we could do this in a column as well, but we're not. We're in the calc section, so let's just type it in. We've got 50 subtract $38.80. You could type this in as 38.8 as well, and it will work. But be careful, because when you're giving your final answer, don't leave it as 11.2. Where we're dealing with money, money should always be to 2 decimal places. So that is the same as $11.20, because in the temps column, there's a 2. In the hundredths column, there's nothing at all, but we can represent that with a 0. Okay, so $11.20. Please always give money to 2 decimal places. Moving on, we'll do a couple more questions where this is part 2, and then we'll look at the others in the 3rd and the 4th video. So in question 8, we're having a look at a field trip, and I feel like this one is a bit tricky, to be honest. We've got a screenshot of the teacher's phone, and it's showing us the direction of north. So let's just focus on that first, because it says the direction of north is shown on the map. So they've got north as being to the left. So if we just put this in, we've got north here. Now that might be different to what we're used to, but I guess it depends on where you are. We shouldn't assume that north is always going to be in a certain direction if we just look straight ahead. That's not true. They've got north as being to the left. So when we do bearings, which is directions such as north, east, south, and west, we just need to bear in mind that they follow a few rules. And one of those rules is that we always go clockwise. So if we go clockwise, if this is north, this means that this here is east, this is south, and this is west. So we're going clockwise. And each turn is 90 degrees. North to east is 90 degrees, east to south is 90 degrees, etc. We do look at the ones in the middle as well, though. So if we just add in a few of those, so we have a line here, and we have a line here, so on and so forth. In between north and east would be northeast. In between east and south would be southeast. Between south and west, we've got southwest. And in between north and west, we've got northwest. Okay? So why I think this is a tricky question. One, the fact that they've put north in a different direction than maybe we're used to when we're doing the standard on a map or the default. But we've also got to read carefully. We're going from the sign from the bench. So where we're going from the bench, we have to start at the bench. So if you start at the sign, you're going to get your answer wrong. And that's a really easy mistake. So you can see I highlighted the sign already. And now I've also highlighted the bench. But because we're going from the bench, we're at the bench and we're going in that direction. Not the best arrow I've drawn, but it wants us to say which of the directions is closest. So let's have a look at the choices that we have. We've got northeast. Well, based on what we've drawn over here, northeast would be heading in that direction. We've got southeast, which looks about right. Northwest, which would be going down here based on the direction of north. and southwest, which would be going in this direction. So our answer is southeast. But again, a tricky one, in my opinion, because we need to bear in mind they said north was this direction and use that to help us figure out where the other bearings are. And we also need to read carefully. We're going from the bench, because if we went from the sign to the bench, we would have got a different answer. Moving on to question 9. We've got a teacher wants to make 81st ribbons for a school sports day. So I'm just going to underline that she wants to make 80 of them. And each ribbon is 12 centimeters long. So which of the following is the shortest roll of ribbon that the teacher requires? So we need 80 lots of 12 centimeters. So I'll just put here, we need 80 lots of 12 centimeters. And where I use the term of, that should be hinting to you. We want to do 80 times 12. So 80 lots of 12. We can use our calculator. Let's just clear it first. 80 lots of 12 is going to give us 960. So we have 960 centimeters. But when we have a look at our multiple choice answers, they're all in meters. So you do need to know your conversions well. And if that's something that you struggle with, I would recommend checking out the acronym King Henry doesn't usually drink chocolate milk. It might sound completely random, but it's one of those sayings that helps you know what order the measurements come in. So the K stands for kilo, for example. So I'm thinking of that in my head, and it's reminding me that if I want to go from centimeters to meters, meters is a base unit, so the U for unit, it's helping me remember that there's 100 centimeters in a meter. So if it's something you struggle with, I'd recommend just searching up that acronym. I now know that if I want to turn this into meters, I need to divide by 100. So 960 divided by 100. We use the calc again, divided by 100 is 9.6. So we need 9.6 meters. We want to choose the shortest roll that we can use. So we need to make sure we have 9.6 or more. So 1 meter, nowhere near enough. But if we didn't do the conversion, or we did the conversion wrong, that might trick us. 7, still not enough. So 10 meter roll is what we will have to choose. We'll have a little bit left over, but that's fine. We want to make sure we have some left over compared to not enough. And then 100 meter roll would just be far too big. Thank you for joining me for this section. In part 3, we'll do the rest of the calculator questions. And then in part 4, we'll look at the non-calc sections that were provided. Hope to see you there.